Hello and welcome to another video. In this video we're going to be working with arithmetic sequences, and we are given that the first term squared over here plus the 19th term squared is equal to 10, and we're trying to find the maximum possible sum of the first 10 terms of this sequence. Pause the video and give this problem a try, and I'll go into the solution now. Okay, so I hope you have given this problem your attempt, but I'll be going through the solution now. So it might not be entirely clear where to start because it seems like we're basically not really given that much information. I will say though, when I see that we're trying to find the maximum of something, then s sub 10 is going to be on the left side of this inequality, less than or equal to something, right? When I see inequality, and I also see the sum of two squares, maybe I'll think of a certain inequality called the Cauchy-Schwarz inequality. But who knows, maybe we don't have to use that in this problem. We'll see. But if that does not come to mind, I would say the first thing to do is to condense everything into just two variables. As you can see, s sub 10 we can definitely write in terms of just a1 and d, which is the common difference. And we can also write over here a sub 19 in terms of a1 and d, the common difference, right? So actually we're going to have everything in terms of two variables, a sub 1 and d. Let's go ahead and do that now. If you know the formula for the sum of the first n terms of an arithmetic sequence, that'll just give us Okay, so all I did was just apply the formula where, 5 is 10 over 2, right? So yeah, I just skipped that step. But also, we can get rid of this a sub 10 because a sub 10 is just a sub 1, the first term, but you add 9d because you're adding the common difference 9 times to reach the 10th term. So let me just rewrite that as well. And this equals to 5 times 2a1 plus 9d. Okay, so that was our sum. Now let's go ahead and write this top part all in terms of a1 and d. a1 is just a1. We don't have to change that. So in parentheses squared, that's just a1 plus 18 of the common difference, right? Because that's how you get to the next term. You add a bunch of d, or the difference. And we are given that this equals to 10. So that's good. We managed to turn everything into just two variables. Okay, and remember that we are wanting to maximize whatever this value is right here. So if we have an inequality, this will be on the smaller side. So s sub 10 is going to be like this, less than or equal to some value. And we are trying to find this value on the right side. Now it might be a little more clear what approach we need to take. So to solve this question, I'll be using the Cauchy-Schwarz inequality. I'm not going to introduce what the inequality is in this video because I'm just going to assume prior knowledge of the inequality, but let's just apply it somehow to get these two in relation to each other. So if you know Cauchy-Schwarz, I'm not sure if I'm pronouncing it right, but it is when you sum the squares of some numbers, right? Sorry, the squares are on the inside, times, and this can be extended for more terms, right? It's going to give you something squared. I'm not going to put in the variables, but as you can see, we kind of have something like that over here, right? We have the sum of the squares of two values, and we want that to equal to something squared. So let's see if we can manipulate this in a way that we can apply the Cauchy-Schwarz inequality. It's clear that this is going to be on the left side, right? And that's actually what we want because it's greater than or equal to, so this will go on the right side. a1 squared plus, I'm just rewriting. Remember, this is this up here, we just changed it, right? This itself is its own thing. And we're going to multiply it by something squared plus something squared. Again, we just want it to fit the form of Cauchy-Schwarz. Okay, and how do we get this to somehow be greater than or equal to 5 to a1 plus 9d. We're going to strategically choose our values. Let's just say x and y, right? We're going to strategically choose the x and y so that we can get this here. Oh yeah, and this entire thing will be squared because that is just Cauchy-Schwarz. To make it a little bit easier to visualize, I'm just going to distribute the 5 over here to both terms. And now it might be a little more clear. So we know that we're going to have a1 times x. Again, this is just what Cauchy-Schwarz says when you have these kinds of things being multiplied to each other in this inequality. Okay, so a1x plus, and then we're going to treat this whole thing as just one value. So don't get confused, you know, there's two terms on the inside, that's just one value in this case. Now we can just set the coefficients equal to each other to solve for x and y. So I'm actually going to distribute the y over here, so a1x plus a1y plus 18dy equal to 10a1 plus 45d. So in front of the a1 term, we have x plus y. So we'll know that x plus y is equal to 10 over here. That's the coefficient of the a1. Something similar for y, we can set 18y equal to 45, so that means y is equal to 5 over 2. Solving for x by plugging y into here, we'll get x equals to 15 over 2. Okay, so we know x and y, we can directly just put it into our inequality. I'm just going to erase these and just put the numbers in. Okay, it looks like we're getting somewhere. And actually, do not forget that we know what this left side value is equal to. That is just up here, 10. And of course, we know what this is. There are no variables there. These are just numbers being added together. So we can solve for the left side and what it equals to. So that'll be 10 times, and I'm actually going to factor out a 5 squared. As you can see, 15 and 5 are both divisible by 5. So I'm going to take out a 25. 25 because it's 5 squared. So that's our left side. And again, we can, find out what that equals to. And it looks like we're definitely getting somewhere. Now remember earlier I actually distributed a 5 to each of these just to make it easier to visualize and solve for our x and y. But now I want to put it back into the form of s sub 10 because that's the whole thing we're solving for. We want to find the max value of s sub 10. We want to isolate it on this inequality. So I'm actually going to try to get this side to look like s sub 10 again. Because if you remember earlier, I distributed the 5 inside just to make it easier to solve for our x and y over here. But now we know what it is, so let's make it look like s sub 10 again. To do that, we can clearly see that both are divisible by 5. So we're going to take out a 5 squared. And that's nice. This looks a lot like our s sub 10 from earlier. We don't have to worry about these exponents of 2 because we can easily just take the square root of both sides. Now let's evaluate the left side of the equation so we can actually do that. 10 times 25. Let's evaluate the inside. That is 9 over 4 plus 1 over 4, which is 10 over 4, which is 5 over 2. We can cancel the 2 with the 10 to get 5, so we see that we have 25 squared. Now this is really great because we can square root both sides. And this is actually s sub 10, right? I'm going to reverse it, so s sub 10 is less than or equal to 25. Thank you so much for watching. Please like, share, and subscribe.